Hi, we talk about probability today. This is a high school level probability course. Now, before I tell you what the chance to get the 7 twice throwing 2 dice, okay, there are some things people often misunderstand about probability. One of them is this: there are some fallacies going around in the casino. Play a game. When you lose, double the bet. If you keep doing that, you eventually win once and get all the money back. Okay, what's wrong with this method? I tell you what, you may lose quite a long time. There is a chance. Okay, and another thing is casino trick is when you keep doubling, it's reached the maximum bet, so you can't double anymore. The casino consider some people may do this, so they have a maximum set for that. Okay, blackjack, yes. Roulette, the maximum pretty high. You can keep doing that, but the trick in the roulette is you keep betting red or black, but there is one non-black, non-red. Occasionally it's hit there and black and red all lose. Okay, so if you keep doing that, you can never win. You have to remember, casino is armed with mathematics PhD, and they consider everything you can think of to beat you. So there's no hole to make a big money in casino. They cover everything you can think of. Okay, so if you really believe that, you can win eventually after betting double every time in the short term, why don't you bet double when you win? You win a lot of money, right? Okay, so it doesn't work. Another thing is, if you play long enough, you will not lose, because win and lose will average out. This is wrong. I'll tell you why. There's no guarantee in the probability that it's going to average out in the short term. When they say flip the coin 50-50, average is 50%. That means if you do infinite times, okay, you do 1,000 times, the head could be 52% or 55%. It happens. That's another probability. So, how the casinos, those PhD, math PhD deal with it? Well, what they do is the average out on every players. So one player play 1 week, multiply by tens of thousands people. That's gonna bring up pretty good average. So one player may win, one player will lose, and casino is perfectly okay with that, because average, they make money. Okay, so another thing is, on a rainy day, I always win, kind of jinx. Some people believe this. Okay, this is psychology issue. There is zero correlation between two events. It's called conditional probability. It's independent or dependent. Okay, the rain, the card delivery on the table depend on rain? No. Okay, so jinx is just psychological effect. Some people thinks that the black spot on the sun is related to stock market, and they get serious about that. Okay, but its so-called event relation is zero. That means it's just jinx psychological effect. Okay?
Do you know why Einstein said God does not play dice?
God does not like to gamble?
When physicists studying quantum mechanics proposed the use of probability functions to describe the position and speed of particles in their field, Einstein rejected that theory. Einstein did not believe that probability was associated with the basic way that nature behaves. Einstein refuted that theory by saying, God does not play dice. Regardless, the use of probability in quantum mechanics became mainstream science. This is the point where science went ahead of Einstein's era.
So mainstream science is like gambling?
You seem to like gambling. Let's use dice to start our lesson of probability. When you roll 2 dice many times, you have more chances to roll 7 than any other number. Do you agree?
Yes, you have 6 possible combinations to get 7, and all the other numbers have fewer combinations.
This is true with 2 assumptions. 1, each event has an equal chance to occur, and 2, each event is independent from the previous event.
You mean any combination listed on the screen has an equal chance to occur?
Provided the dice are made evenly, I mean not skewed, the chance of rolling 2 ones is the same as rolling a 3 and a 5. There are a total of 36 different combinations. Each combination has a chance of 1/36.
I agree with that.
Then do you also agree that the chance of rolling a total combined number of 7 is 6/36 because there are 6 different combinations that produce the total number 7?
Yes. Is this the probability?
Yes. The probability of getting 7 with 2 dice is 6/36. Now, if you roll again, would the probability of getting 7 be the same?
Yes, why not? It is just another roll, so it can be any of the number combinations. Each combination will have the same chance of appearing again. If I get a 7 this time, it does not reduce the chance of getting a 7 the next time.
Correct. The event is independent from the previous event. It is called an independent event. What about the probability of rolling 7 the first time and rolling 7 again the second time?
The first time, the probability is 6/36, and the second time, it is also 6/36. The probability of getting 7 twice would be...
This is an example of conditional probability. The second event is conditioned by the first event. The conditional probability is obtained by the first probability multiplied by the second probability. 6/36 multiplied by 6/36, yielding about a 2.78% chance.
Wow, it is a very small chance.
For independent events, the conditional probability is just another roll of the dice, and it will be exactly the same. 6/36 for the second time rolling. Probability can be expressed in the form of a graph, and it creates a distribution function, as you see on the screen. Again, we can calculate the probability for this event from this distribution function.
I've just learned this in statistics.
This probability distribution graph becomes very important in acceptance sampling. When you have a factory producing products and you need to perform destructive tests to see if the product is good or not, you cannot test every unit, right?
Like fireworks? If they tested all the fireworks made in the factory, there would be nothing left.
The factory uses only a few samples for testing and then estimates to see if the products made in this factory are good or not. How many samples should they test?
The more, the better.
The more you test, the more product you lose. So they use math to estimate the size of the sampling that will give them enough confidence that the product is good quality. This is actually done in almost every factory.
I see.
Acceptance sampling is the key topic of mathematics that is used widely in quality control. It is used in commercial applications, like we just mentioned, as well as in military applications. We have covered all the basic aspects of probability here. You can try some sample questions in the worksheets.